Hello everyone, Michael here with Cerulean Sonar. Today I'm going to walk you through the process of calibrating your ROV locator. Regular calibration of the ROVL is necessary for accurate positioning, as IMUs can be affected by environmental factors and drift over time. Before we begin, let's connect our ROVL and fire up the Cerulean Tracker application. First, connect the unit to one of the available USB ports. You can confirm that the unit is on by the LED on the serial to USB cable. Launch the Cerulean Tracker app and select the ROVL RX tab. On this panel, make sure the Show Command Window checkbox is checked. In the ROVL command window, press the CIMU Calibrator button. This will open the CIMU Calibrator window. There are three components of the IMU that need calibration: the gyroscope, magnetometer, and accelerometer. Let's start with the gyroscope, or gyro. Over time, gyros can be affected by aging and temperature changes, so we recommend recalibrating every 3 to 6 months. This calibration must be done somewhere stable, so this won't work on a rocking boat. To get started, place the unit on its nose on a stable surface and click the Calc Gyro Cal button. At this point, simply wait and avoid moving the device while it collects several hundred data points. Once the points are collected, let the device sit for a minute. On the screen, the cube should only move slightly back and forth. If the cube drifts significantly, click the Calc Gyro Cal button to retry the calibration. When you're satisfied that the cube isn't drifting significantly, click the Commit Gyro button to save the calibration. Now let's move on to calibrating the accelerometer. Like the gyroscope, accelerometers are affected by aging and temperature changes, so we again recommend calibrating every 3 to 6 months. Be sure to perform the calibration on a stable surface. To begin, click the Calc Accel Cal button. You'll see a display showing 3 positive and negative axis indicators, representing signal levels for each of the 3 main axes. The objective is to align the axes with gravity to capture the maximum signal in both the positive and negative directions. Since there are 3 axes, and we need the max signal in both directions for each, you'll need to position the device in 6 different orientations. The device will need to be kept stable in each position long enough to collect data, which is about 1 second. You can use the cap mounting screws to reference the X and Y axes, with the Z axis running vertically through the receiver. To maximize any one axis, try to minimize the other 2. Watch the screen as you move the device and aim to find a position where one axis is maximized while the others read close to 0. The background color of each axis give a visual guide. A gray background means the axis still needs to be collected. An orange background shows gravity is aligned, but the device needs to remain stable a bit longer. A green background confirms the axis data has been successfully collected. Once all 6 axes are collected, you can click the Commit Accel button to complete the calibration. Finally, let's move on to the magnetometer. Magnetometers are highly sensitive to magnetic disturbances and variations in the Earth's magnetic field. For the most accurate calibration, it's crucial to perform this process in the area where you'll be operating the ROVL, while avoiding any magnetic interference from large metal objects or strong electrical currents. If you move more than 50 kilometers from your calibration location, or if magnetic conditions have changed, it's recommended to recalibrate. Unlike the gyroscope and accelerometer, the magnetometer calibration does not require a stable surface. To start, click the Calc Mag Cal button. Then pick up the device and move it around in the air. As you move the device, you'll see dots appear on the display. The goal is to evenly distribute these points, forming a sphere. A helpful approach is to align the device with each of the 6 cardinal axes and slowly spiral outward. Afterward, move the device randomly through space to fill in any gaps. Poorly distributed points can lead to inaccuracies in the calibration. Once 1,000 points have been collected, the system will stop recording. If the points appear evenly distributed, click the Commit Mag button to complete the calibration. If not, you can click the Calc Mag Cal button to retry. Thanks for watching. For detailed instructions on calibrating the ROVL and additional information, please refer to our documentation linked here.